Today we're going to be working on half of the fifth set of notes. Obviously we've done a lot of work on solving polynomial equations. Today I would like to highlight to you the type of polynomial equations you will see on the PARCC test that you're going to take in March and in May. So the very first example is the second problem that is on the practice PARCC. So here is a real life application of a problem you would see on the PARCC test. When you look at this problem, it looks extremely complicated and it looks like you don't know how to do this. However, with a little manipulation, this problem is not that difficult. When I look at this problem, I have a fraction, and if I would like to clear my fraction, I need to multiply both sides by the denominator. So the denominator means the bottom of the fraction. So I'm going to multiply both sides by the denominator of the fraction. So I'm going to be multiplying both sides by x squared plus 4x minus 5. And whatever I do to one side, I have to do to the other side. So by doing that, this over here is going to cancel with the bottom over there. So that means I'm now going to not have a fraction anymore, and I'm going to be left with 2x squared plus 3x minus 5. Notice on the right hand side I put it in parentheses so that you can clearly see that it's 4 times that entire trinomial. So I'm going to distribute that 4 in. So it will become 4x squared plus 16x minus 20. Now I've cleared the fraction and now I have 3 terms on each side respectively. And if I'm trying to solve for x, the goal is that I always have to have it equal to 0 and I want all my terms on one side. I personally prefer to have a positive a value, so I'm going to subtract the 2x squared over. I'm going to get all my terms on the right hand side. So I'm going to subtract my 2x squared from both sides. I'm also going to be subtracting my 3x from both sides. And I'm going to add my 5 to both sides. Notice by doing this, everything's going to cancel on the left hand side, so it's going to be equal to 0. And on the right hand side we'll have 2x squared plus 13x minus 20. So in 2 steps I've now cleared this problem and made it look like a very simple quadratic trinomial. So again, we multiply both sides by the denominator, then get all the terms on one side. Now this breaks down to regular factoring. So I'm going to multiply my a times c value, and actually this should be not negative 20, this should be negative 15. So I'm going to multiply my a times c value to find the combination that adds to be b. So I'm going to flip the screen so I have more room. So we had 0 equals 2x squared plus 13x minus 15. So a times c, I'm looking for the combination that multiplies to be negative 30 and adds to be a positive 13. So the combination that we're going to use is a positive 15 and a negative 2. So box, factor, whatever method you use, we're going to go ahead and write out this so we can group them. So I'll have a 2x squared plus 15x minus 2x minus 15. Boxers, go ahead and draw your box. Put all 4 terms in the box. We group my first 2, I group my second 2, and I determine the largest quantity that we can take out. So the largest we could take out, my GCF that I could take out of my first binomial, is an x. So I would be left with 2x plus 15. My other quantity, I could take out a negative 1, and I'd be left with 2x plus 15. So from here, it will factor down to be x minus 1 and 2x minus plus 15. Now I know we see that 0 equals on the left-hand side. It does not really matter what side you put the equal 0 on, so I'm just going to now move the equal 0 back to the right-hand side. They wanted you to solve. They want the 2 answers. So my 2 answers, I would set each binomial equal to 0. So obviously the first quantity would give me an answer of 1. The second quantity, if I set it equal to 0, so if I set this equal to 0, we would have plus 15 equals 0. We'll subtract 15 from both sides. So 2x equals a negative 15. Divide both sides by 2, and x equals negative 15 over 2, or you could say negative 7.5. So here are your two answers, a positive 1 and a negative 15 over 2, or you could say negative 7.5. So either or would work. So that is your first example, and that is basic factoring. Example 2 is a polynomial, so it's a cubic polynomial. Again, we have terms on both sides, so the goal is that I need to get every term on the same side of the equal sign. So I'm going to move this 4x squared over, and I'm also going to move this 12x over by subtracting them over. And now we will have 5x cubed minus 4x squared minus 12x equal to 0. I have three terms, so factoring by grouping is not an option. I have, again, three terms, so sum of difference of cubes is not an option. I have to look at it and determine if it's factorable. Now, before we even determine it's not in quadratic form, I can take out a GCF. So if you can take out a GCF, you should always take out your GCF. 5, 4, and 12, numerically wise, I can't take anything out, but I could take out an x from the entire quantity. So I'm going to factor out an x, and I'd be left with 5x squared minus 4x minus 12, and it's equal to 0. So now it's a basic factoring problem, so we're finding the combination that multiplies to be negative 60, and I have to find the combination that adds to be a negative 4. The combination that we're going to be using is a 10 and a 6, and I need it to add to be negative 4, so therefore it needs to be a negative 10. So my boxers, go ahead and make your box. My foilers, go ahead and foil. I'm going to do the box one since I haven't done that recently. So I have a 5x squared, a negative 10x, a 6x, and a negative 12. And we're finding the outside. So my first column, I can take out an x. My second column, I can take out a negative 2. My first row, I can take out a 5x. And my bottom row, I can take out a 6. So this will factor down to be x minus 2 and 5x plus 6. However, there was still that x out front that we factored out from the very beginning. This is a cubic function, so it's a degree of 3, so I should get 3 answers. So my one answer is 0. If I set x equal to 0, I get 0. This answer will give me positive 2. And the last binomial, I have to do a little bit of work. If I set it equal to 0, I would subtract 6 from both sides and then divide by 5. So we get an answer of negative 6 over 5. So those are my 3 answers for this equation. We're going to pause for today, and we'll pick up with the other 2 examples tomorrow.